This is Mrs. Minowitz, and I'm here to talk to you about the atmosphere and get us started on our meteorology unit. So the first thing that I would like for you to do is I want you to watch a different YouTube video called All About Weather Balloons. And to get there, you're going to look for a playlist called Student Access and then click on the All About Weather Balloons and watch that. So right now, I want you to go ahead and pause the video. All right, now that you've watched that video, we're going to move on to talk about some other things related to the atmosphere. So we're going to start with a pretty common question, one that kids ask all the time, and that people often get wrong or have some different ideas about and get kind of backwards. So our question is, why is the sky blue? The sky is blue because molecules in the air scatter blue light from the sun more than they scatter red light. When a person looks toward the sun at sunset, he or she can see red and orange colors because the blue light has been scattered out and away from the line of sight. And a lot of times when I ask students, they get slightly confused because they're like, oh, it's blue because of the ocean. Well, the ocean is blue because of the sky, and it's reflecting back that bluish color. The atmosphere is just a mixture of gases surrounding Earth. It is not a pure substance. It is a mixture. You could separate the different gases that make up the atmosphere, so it is a mixture. And it is a mixture of a bunch of different gases, but the most common ones are listed here. It is 78% nitrogen and 21% oxygen. Most of the time people think that the atmosphere is mostly made out of oxygen because we talk about it so much when you talk about like breathing in, but actually you're breathing in more nitrogen than you are oxygen. It's just that your body doesn't need it like they do oxygen, so you breathe it back out. There are other gases in our atmosphere as well, some things like carbon dioxide, water vapor, argon, but the most common ones are nitrogen and oxygen. So if you take a look here at nitrogen gas, okay, if you look back at your periodic table, nitrogen is atomic number 7. It has 7 protons and 7 electrons. And if you look at its outer shell, there are 5 electrons in the outer shell of nitrogen. And that's not too happy because the outer shell, they want to have 8 electrons to be full. So what happens if you look here is you'll see that 2 atoms of nitrogen will bond together and they will covalently bond, they will share those electrons so that they've got 6 sitting in the middle and 2 more on each side makes for 8 in that outer shell, and it's much happier that way. So in the atmosphere you will see nitrogen listed as N2 because it bonds together and we've got 2 nitrogens put together. The same idea also happens with oxygen. Oxygen is atomic number 8. It has 8 protons, 8 neutrons, and 8 electrons. And if you look at those electrons, there are 6 on the outer shell. And again, it doesn't like 6, it wants to have 8. So if it shares 2 for each one, we get 4 in the center there and 4 on the other part of the outer shell, and you get a total of 8 electrons in that shell, and it's much happier. And oxygen we would write as O2. You don't just write the letter O because oxygen in the atmosphere doesn't exist as just a single atom. It is a molecule that's been of 2 oxygen atoms bonded together. Okay. So if you look at the layers of our atmosphere, so you can divide our atmosphere into different layers based on the different properties that exist there. So if you look here, we've got 5 different layers. And if we had Earth would go down here on the bottom. Because Earth would be right, if you move right above the surface of the Earth, you have the troposphere. And this is where most weather occurs, and it also has the highest density. If you keep moving upwards, you hit the stratosphere. And this is important because it contains the ozone layer, which helps to keep us safe from the sun. And I'll talk about that more in a minute. There's the mesosphere, which is the coldest layer. And we'll talk about why. And as you move up, we get to the thermosphere, and the exosphere is just kind of leading us off into space. But those are our layers of the atmosphere. If you look at this chart here, this kind of diagrams what's happening in the atmosphere. So on the left here, we've got pressure. And if you look as altitude increases, so as we go up in the atmosphere, we have less and less pressure. And that makes sense because there are fewer air molecules on top of you. Think of it like if you went into a pool, you go down deep, you start to feel more pressure because there's more and more water on top of you. Same idea in our atmosphere, except it's with air molecules. If you go further and further down, there's more and more pressure, and that's where we're at the bottom of the atmosphere if you're on the surface of the Earth. The right-hand side of this diagram shows us what's happening with temperature. And it's not a really simple relationship between altitude and temperature. It depends on what's happening in the layer that you're in. So if we're down here on the troposphere, as we go up in the atmosphere, it gets colder. Okay. And this, if you think about it, makes sense. If you were to go to the top of the mountain, it would be colder there than it would be on the surface of the Earth. However, as we move up into the stratosphere, it starts to get warmer there. And the reason why it starts to get warmer there is because of this thing here called the ozone layer. Now, the ozone layer is actually made out of oxygen. It's O3. And what it does is it blocks radiation from the sun. It absorbs a bunch of radiation, so that helps keep that layer warm. It's super important because if we didn't have the ozone layer, all the radiation from the sun would make its way to the surface of the Earth, which would be bad for us to have that much radiation. So it's super important. Then as we move past the ozone layer and we're going up in our atmosphere, in the mesosphere, it starts to get colder again because there is no ozone layer keeping it warm there. And then finally, as we go up, move up into the thermosphere, it starts to get warmer again. And this is because we've reached the outer layers of the atmosphere and we're starting to see there's more heat from the sun because we're getting closer to that. So this kind of shows what happens with the different temperatures when you are in different parts of the atmosphere. One of the things with the troposphere is that it also has the highest pressure and highest density. So I would make sure to include or add onto your diagram that where it has higher pressure, there's higher density. Okay. And remember, your density is the amount of matter in a given space. We're on the bottom in the troposphere here. There's more air molecules pushing down and as compacts the air molecules, we have more air in a given space, and that means that it has a higher density. Think about if you went from sea level up to the top of Mount Everest, there would be fewer air molecules as you were there, which makes it, again, harder to breathe because there's less oxygen in the air. Mount Everest is at about 29,000 feet, so that's approximately where planes are at. Planes would be above that, right there at the top of the troposphere, because they usually fly 30, 35,000 feet. Okay. All right, we're going to shift here a little bit onto air pressure. Air pressure is, again, how much air we have in a certain area pressing down. And what we've got is that high pressure is associated with fair weather. It's going to be sunnier out. There's not going to be as many clouds in the sky. You're not going to see storms. It still might be cold. High pressure does not mean high temperature or does not mean it will be warm, but it does mean that weather is usually nicer or more fair. When we have a low pressure, that's when we are more likely to get stormy weather. And we'll talk about more as we move on in class with that. Now, to measure or determine air pressure, a tool called a barometer is what is used. I want you to see a little bit about how a barometer works. So I want you to pause the video in just a second and go watch the video under the Student Access playlist called Barometer Device to Calculate Air Pressure. All right, now that you've learned about the barometer, it gives you some background information as to how it works. And again, they can be made of different things. A lot of times it's mercury. So oftentimes you will see for a unit, mmHg, that stands for millimeters of mercury. You don't have to use mercury, but it's a pretty common thing. Hope you learned something about this. We'll continue this more in class. Have a good day.